Scientists extremely shocked by NASA's telescope discovery of alien megastructure. Astronomers are baffled by a distant star that the James Webb Space Telescope captured in July and has odd concentric geometric waves surrounding it. This image has also spurred hysterical internet speculations that the light may be evidence of an alien megastructure. Now, astronomers have a unique opportunity to examine the gentle brush of light on two odd stars' dusty skirts as they spin around one another in a sweeping, chaotic waltz. The image, which resembles a kind of cosmic handprint, was captured by NASA's newest flagship telescope, the James Webb Space Telescope. The internet suddenly became flooded with theories and speculative material. Some outlandish folks even claimed it was evidence of alien megastructures with an unidentified origin. The WR-140 is a binary system surrounded by several nested shells of dust being slowly ejected into space by both stellar winds of charged particles coming from the pair and the stars themselves. Researchers could follow a large plume as it extended into space over 16 years using infrared data from the Keck Observatory, offering the first direct observation of this radiation pressure in operation. The WR-140, a rarity among rarities, is located about 5,600 light-years away and is a star located in the Cygnus constellation. An extremely uncommon Wolf-Rayet star and a blue O-type supergiant star combine to form what is known as a colliding wind binary. This explains what we observe in a recent image captured by the James Webb Space Telescope, which depicts the blazing binary cuddled amid a dizzying array of bright dust shells. Wolf-Rayet stars burn extremely hot, brightly, and anciently, and are in the final stages of their main sequence lives. They are abundant in nitrogen or carbon, have a significant lack of hydrogen, and are losing mass quickly. This lost mass also contains a considerable amount of carbon, which absorbs solar radiation and emits it again as infrared light. On the other hand, O-type stars are among the most massive stars ever found. They have short lives, only a few million years due to their large size, and are also extremely hot and luminous. While all stars create stellar winds, those from Wolf-Rayet stars resemble stellar hurricanes more. Both of the two stars in the WR-140 system generate powerful stellar winds that travel out into space at a velocity of around 1,864 miles per second. Both stars are rapidly losing mass, which is quite normal. The stars' orbits, however, are not circular since they revolve around one another in an elliptical pattern. They come together for a close approach, then spread out again to a far distance. When their powerful stellar winds collide, shockwaves are produced at the periastron and a large cloud of dust is released outwardly, forming a dust shell. Windborne materials like carbon condense out as soot, which is still hot enough to shine brightly in the infrared. The stars orbit each other every 8 years, and each new ring forms 8 years after the one before it. Systems like the WR-140 offer good research subjects for the study of dust generation and acceleration due to their consistency. According to Professor Peter Tuthill of the Sydney Institute for Astronomy at the University of Sydney, WR-140 emits a sculpted smoke ring every 8 years, inflated like a balloon by the stellar wind. 8 years later, as the binary returns to its orbit, another smoke ring appears, identical to the one that came before it, spilling out into space within its bubble like a series of massive stacked Russian dolls. You may have noticed that the rings surrounding the WR-140 are oddly shaped, with one side stretched out into what is known as a squircle shape. The squircle shape is challenging to understand solely from the star's winds. In the absence of external pressures, each dust spiral should grow at a constant speed. The first source of uncertainty was the researchers' failure to match the observations obtained from the images to their 3D model of the binary system. Nevertheless, they quickly realized that they were indeed witnessing something new. The expansion speed of the dust spiral was accelerating rather than remaining constant, which is why the data did not match. However, there is another justification behind that. Radiation pressure is that. It is believed that starlight has momentum and pushes matter with a force known as radiation pressure. Over 16 years, Hahn and Professor Tuthill monitored huge dust plumes caused by the catastrophic collisions of two big stars and provided direct evidence of intense starlight accelerating matter for the first time. Electromagnetic radiation, or light, exerts very little pressure on anything it collides with due to the photon's momentum being transferred to the surface. Photons are so tiny and massless that they won't affect your daily life, although stars generate a lot of powerful radiation. When unfiltered and in an environment without gravity, this radiation has the power to move matter. This is the concept behind light sail technology. Astronomers have never seen this process in action, but they routinely witness its byproduct, which is matter coasting quickly through space. Direct observation of acceleration brought on by forces other than gravity is uncommon and never seen in a cosmic environment like this. It's quite challenging to see starlight causing acceleration because as the force declines with distance, other factors will quickly take over, says astronomer Yin-Hu Han of Cambridge University. To witness acceleration at a level where it can be quantified, the material must be very close to the star or the radiation pressure from the source must be quite high. These impacts are intensified by the binary star WR140, whose ferocious radiation field allows us to detect them with high precision. Scientists discovered that dust did not stream out from the star with the wind, creating a hazy ball as was previously thought. Instead, the dust lands directly where the winds from the two stars collide, on the shock front surface. The circling binary star's continuous motion causes the shock front to rotate. The sooty cloud spirals around itself like water droplets do in a sprinkler in a garden. When the scientists incorporated radiation pressure into their three-dimensional models of the WR140 binary, they could replicate the peculiar shape of the shells that were ballooning around the binary. It ultimately helped to explain the strange concentric circles that JWST detected. In a sense, we always knew this must be the explanation for the outflow, but I never anticipated we'd be able to watch the physics in action like this, says astronomer Peter Tuthill of the University of Sydney, Australia. Looking at the data, I can now see WR140's plume spreading out like a massive dust sail. When it captures the photon wind blowing from the star, it immediately accelerates like a yacht receiving a gust. The first spatially resolved mid-infrared spectra of a dust-forming WR binary were obtained by researchers when they studied WR140 using the medium-resolution spectroscopy mode on MIRI of the James Webb Space Telescope. This allowed them to probe the chemical signatures of the dust shells directly. The broad and prominent features of the dust in the spectral lines at 6.4 and 7.7 microns were compatible with photosilicic aromatic hydrocarbons as its constituents. The carbonaceous element, whose origin has long been a mystery, is essential to the interstellar medium and the formation of stars and planets. Thanks to the combined MRS spectra and MIRI imaging data from JWST, we now have evidence that WR binaries can be a significant source of carbon-rich chemicals that improve the interstellar environment of our galaxy and possibly other galaxies. Researchers believe that this new technology will make it simpler to conduct investigations than those done on the ground, leading to fresh discoveries in the field of Wolf-Rayet physics. The universe is packed with extraordinary things indeed. And on that note, we have come to the end of this video. Do you think the new technologies can provide more insight into other binary systems like the WR140? Let us know in the comments section. Don't forget to give this video a thumbs up, smash the subscribe button, and turn on that notification bell to get notified when we post a new video.